Welcome to another video in the series, and today we are going to explore Traffic Manager. Yes, we did talk about Traffic Manager in previous video, the exact concept, how exactly it works, and a lot more. But today we'll wrapping it up with routing methods. Yes, we need to go through all the methods in detail with the understanding when to use which one, right? So that we can cover the traffic manager once for all for this series, of course. So let's get started. Traffic manager, for the sake of this video, is a DNS based traffic load balancer. We have a huge discussion on this yesterday or the last video. So it's a DNS based traffic load balancer that enables you to distribute traffic across your public facing applications. Yeah, your public facing applications, whether they are hosted within Azure or externally. So what are those? There are three kinds of endpoints we talked about: Azure, external, and nested. Right, so by directing client requests to the most appropriate service endpoint based on your chosen traffic routing method. So when we create traffic manager, what we create profile, right? And the profile, we select the routing methods. And today we are going to explore this routing method, right? So what are the routing methods that we have in traffic manager? As we showed you in our previous video, there were like so many, right? So the session has expired already, but don't worry. While it is getting in, I'll show you. The very first method is method number one. Method number one is priority. Priority. As the name says, we gonna give the priority to send all the traffic to that particular site, and we'll give less priority to maybe the standby on the secondary side. If something goes off in the primary side, the traffic will be diverted to the secondary side. So let's suppose this is our users, okay, and in the priority we gave this is like P1, or this is the primary side and these are the secondary sides. So let's call them primary and secondary. So whenever a user will try to access uh, abc.com or whatever is hosted in these sites, the request will come via the internet. The DNS thing will happen that showed you yesterday. So just simply go traffic manager profile. It will see that I need to give the information of primary profile only, so that the request will directly connect to the primary site. In case this doesn't send the health probe or monitoring fails for the primary site, this goes down. Only in that case it will give the secondary site information to the user request, and then client will connect to the secondary site. This is what it exactly means, right? Okay, let me build this thing here first. All right, so priority routing, it designate a primary endpoint for all traffic with backup endpoints in case of the primary goes down. In case of primary goes down or becomes unavailable, traffic will be redirected to the highest priority endpoint or the healthy endpoint. Right, so this is what the priority routing is. Now, when to use this kind of routing? Well, whenever we have one site as a preferred for all traffic, like the primary site and DR site, or if you need a strict failover mechanism that by default goes with the same kind of scenario, like for DR scenarios when a secondary region takes over if the primary fails. If you have that kind of situation, you can utilize this kind of routing method. Simple, very nice. Now the second routing method is weightage or weighted. Here we give the weight, like for example, the request which is coming, like 100% request comes here, and we have given like 50, or maybe let's call it 40, or call it 40, or maybe 10, right? So whatever traffic comes, it will get distributed accordingly. If this goes down, then most of the requests will come here, like out of 5, 4 will go here, 1 will come here. It is weighted routing. Traffic is distributed among multiple endpoints based on the assigned weight. So each point is given a weight. It's not the value goes from 1 to 1000 when we configure it. I just, for the sake of understanding, I gave the example of 100, or it was 90. It should be 20 here, right? So 1 to 1000, and higher weight means more traffic is directed to that endpoint, right? Higher weight means more traffic will be directed to that endpoint. Now you can give 1000 to 1, okay? Then all traffic will come here. Or you could say, 910, but in that situation, even the secondary would be utilized. One or two requests will go to the secondary side out of thousands. That's why in priority, all the requests will go to the primary side, not on the secondary side. But in weightage or weighted, we give weight. Even if we give 10%, the 10% request will go there. Okay. Now, if you're wondering when should we use it, just think about it. We can use it when we are rolling out a new version of an application, like A and B testing, right? Like A B testing, where we would like to give the weightage like 10% to go to the new updated version of the application, and rest will be on the old version. And once we have the positive feedback, once we are aware everything is fine, we can keep on increasing the weight, right? Or for load balancing between regions with adjustable traffic routes. So this is the scenario. Or if we need to load balance between the region, this weightage can help you do the load balancing. Okay, that's the reason we also say DNS based traffic. However, it act as a load balancing, right? So or if you want to control traffic distribution explicitly between the endpoints, so you can control through the with the help of this weightage routing. Then the third one we have performance routing. As the name says, it depends on the performance, which means traffic is sent to the endpoint with the lowest latency, which means best performance relative to the user location. If somebody is trying to access from here, okay, let's forget the geography, US, Europe, and India. Let's suppose if this guy is sitting in India, then of course it will send the traffic to India after doing the dance, coming here and going back, right? So India. If this guy is sitting in US, then the traffic will go to the US. Low latency, like less distance, right? All right, so that's the performance routing. And it dynamically adjusts the routing decision based on the real-time network conditions. Yes, if you have like 2 or 3 regions nearby, this works as well. So Traffic Manager checks network latency between Azure regions and user locations and divert it accordingly. So when should we use performance routing? Well, when we have to minimize latency, or the performance is the highest priority. And for global applications where users are spread across different continents, right? And if you want users to connect to the closest available data center automatically, the point is the performance. Right? So let's understand the fourth one. Fourth one is geo or geographic. All right, it seems like the geography of the locations, regions, right? So how it works, traffic is routed based on the geographic location of the user's DNS request. User's DNS request. Okay, all right. And you can define specific regions like all US traffic must go to the US endpoint. For example, if there is some kind of series which is banned in India and not banned in US or vice versa, then we would like all users coming from India to go to the India endpoint. Okay, this is not based on latency but on the user location mapping. So as the name says, we are trying to restrict some kind of, we are trying to put restriction. Okay, so it seems like the use case will definitely, one would be the compliance, right? Where we would not like to show our data to the other folks, or we don't want to expose our people or to the data which is not supposed to be for them as per the government or the compliance. So when you want to serve different continent per region, like US have US endpoint, Europe have Europe endpoint, India has India endpoint. So in that situations, geography is the ultimate choice. And if regional licensing or contract agreements limit where services can be accessed, there you go, geography. All right, then what is the fifth one? Fifth one is multi-value. As the name says, the return is multi-value. All the active endpoint will be returned to this request. Request comes, DNS will give the information of all the active endpoints. So returns multiple healthy endpoints in the DNS response instead of just one. So the client chooses which endpoint to connect to. If an endpoint fails, client can retry with another available endpoint. And when should we use this kind of option? When we want clients to have multiple failover options, and if we need redundancy at the client level instead of relying on a single DNS response, when application requires multiple IPs for resiliency. So if request is such, multi-value is your choice. All right, this is the last one, and this is most interesting and complex. Okay, let's understand subnet routing. Now you'll be wondering why subnet, because subnet means private and we already established we do public. Here it comes interesting, right? So let's see how it works. Traffic is routed based on the source IP address. This is the source, right? Source. So traffic is routed based on the source IP address of the user. You define a specific IP address range that should be directed to this specific endpoint. So in the traffic manager in subnet routing, we have defined, right, like up to slash 24, it will go to this endpoint, uh, XYZ, XYZ to ABC range will go to another endpoint, right? And accordingly, it will send the request. So you define specific IP address range that should be directed to the specific endpoints. So the source IP will get checked here, and as per the routing method, they will identify what kind of IP address that they have, and it will send to that particular endpoint. So subnet-based routing ensures that specific IP blocks always reach designated regions. So when you need strict traffic segmentation based on user IP addresses, that's your choice. If different customers like internal or external users require different service versions, we can go with the subnet. Or I could give you another example so that you can understand the subnet routing better. Let's suppose there is a company with internal user like employees and external consumers. Okay, internal like employees, and they have an external like consumer, right? like Azure AD for our employees and Azure AD B2C for the consumers. Similarly, we need to configure corporate traffic for internal users such to so that it will go and hit the internal endpoint, internal app endpoint. When the source IP is IP that belongs to the internal. And if the IP is external, like consumers, then it will hit the external app endpoint. Getting my point? That's how it's done. External app endpoint. Like you have seen, not exactly like this, but when you access your internal website through internal DNS, and when people accessing your website from outside, then they go through the public DNS, more or less like this. When your IP is found, like internal IP of your employees, then it will direct to your application internal endpoint. If it is external, then it will direct to the external endpoint. So it will the use case that we're talking about, if different customers like internal or external require different service versions, when ensuring that certain user groups always use specific infrastructure. In that situation, this is just an example, like this is not always true internal external, this is just an example where we need this segregation, like certain user groups always use specific infrastructure. All right, so when you need strict traffic segmentation based on user IP addresses and you are aware of that, so you can configure it accordingly. So these are 6 routing methods that we have in our traffic manager profile and 3 endpoints. And all these 3 construct our traffic manager profile and we can utilize it as per our requirement. All right, just to conclude, priority routing method best for DR and failover scenarios, weighted for gradual rollouts, A/B testing, load distribution. Performance is low latency. Geography is all about data compliance, regional access control, and multi-value provides redundancy at the DNS level for highly available applications, and subnet routing controls which endpoint user are directed to based on their IP ranges. With this, let's close the video. I hope it was interesting and you guys liked it. Thank you for watching and you have a wonderful